Okay, very good morning to all of you. So, in the previous class, we have discussed something about the assignment. I haven't posted this assignment to you people so far. So, however, today I'd like to post the assignment through Google Classes, and I'll give you the due date also to complete the assignment. However, so we have completed unit number 5 in the previous sessions. So recovery management has been completed and everything has been completed properly. And today we would like to discuss uh, unit number 6, a very important unit. And you could have approximately 16 marks from this particular unit. And it is very easy also because you people have studied this particular unit in your ADS, Advanced Data Structures also. So everything is very easy, pretty much easy, and how the things are being going on in data structures here also the same. But here we would like to discuss everything in terms of databases, not in terms of the data structures. What we have already you have taken the data structures or advanced data structures in the previous semesters. However, so this unit is mainly focused on two different types of things. Number one, so data storage, how the data can be stored on disks. What are the different kinds of data storage units are available for you for databases? And a very pretty much important thing is indexing. This is very important because so indexing is one of the specific kind of operation where exactly the data will be, picked up from the databases or secondary storage devices at a huge faster rates. So that is why index is very much important. Of course, indexing could be discussed by us probably the third class right away from today's class onwards. So we would like to consider so today data storage, how the data will be stored, and how the things are being accessed here. Everything will be discussed today. So this particular discussion will be very formal discussion. Already you have learned this particular discussion in your previous courses such as IT workshop or some other courses which we have taken already in our previous semesters. Okay, so sorry. So let's get started without any delay. So look at this. The specific points which we have to concentrate on this particular unit will be storage and indexing. So basically, it is concentrates on storage and how the data will be picked up with faster rates at faster rates. So it could be. So these things are going to be learned by us in this particular discussion. Probably coming 4 to 5 sessions, we would like to concentrate this particular unit here. Okay. So, however, we would like to concentrate on this particular storage today. So, let us have a look regarding to this particular storage. Look at this. This is the complete information or snapshot where the database will be stored its data or will be retrieved its data from any kind of database here. Okay, any kind of secondary storage or any kind of storage structures here. Okay, look at this. So at the bottom line, we do have a cache memory. Of course, underneath of this particular cache memory, we do have one unit. That unit is called a CPU, Central Processing Unit, otherwise microprocessor. Microprocessor will be available here. So of course, everything will be done and every operation will be done by using microprocessor only. So that we are not interested to show this particular microprocessor unit or central processing unit in this particular diagram. We are mainly concentrate on only storage here. So here cache memory is one of the fastest memories of the computer because the microprocessor, for example, let me draw one particular point here. So that point is very important to know here. For example, computer the microprocessor will be executes at 100% speed. For example, if you consider in such a way, so I'm taking this particular 100% for why it could be taken into consideration. To explain in a proper way, I'd like to take this particular 100% here. It is executing the instructions which are fetching from main memory at 100% in the sense. So cache memory can be worked out, supply the instructions to the microprocessor at 90% speed. 90% speed. For example, if you are taking one particular example in terms of a number per second, a microprocessor could be executes so 10 instructions. Is only for example for better understanding point of view. I am discussing this particular example. For example, microprocessor will be executes so 1,000 instructions per second. Then cache memory will be supplies to the microprocessor approximately up to 900 instructions. So 10% of time will be ideal by the microprocessor because cache memory can be worked out up to 90% only. And if a CPU wants to get the information, so right away from not from the cache, and it could be directly fetch the data from main memory in the sense. For example, this is the orientation. We would like to consider there is no cache in between CPU and microprocessor. For example, if you consider something like that, there is no cache memory between the CPU and the microprocessor. Sorry, main memory. Then main memory can be supplied. So how many instructions per second here in the sense it could be supplied. So only so 60% of instructions. For example, microprocessor can be executed 1,000 instructions per second. You please remember this 1,000 number. 1,000 instructions per second. Then, so main memory can be supplied or give the instructions or supply to the instructions to microprocessor up to only 60%. That is 600 instructions per second will be so loaded to microprocessor. If you don't have any cache memory here, then the ideal time of CPU will be 40%. Okay, 40% of the time will be ideal if you do not have any cache memory with you. And then, so if without main memory, this virtual memory or disk or file system, so cannot be taken into consideration. These things cannot be taken into consideration. Main memory must be there within the computer, so that so the data which actually stores at the file system, otherwise at the disk, or otherwise so at of course virtual memory is not at all a specific memory here. So let me explain what is virtual memory after a couple of minutes. So at the file system or a disk, so-called instructions or so-called data will be stored. Fetching of data from file system or disk will be the rate of fetching of instructions or data from the file system or disk will be so 40%. Okay, 40% only. So main memory can be fetched the data from file system or disk at 40% rate, and it could be so give the input to the microprocessor directly without cache will be at the 60% rate. And if you put the cache in between microprocessor and main memory, it could be work out approximately 90% here. So that is why cache memory was introduced in between main memory and microprocessor, so that the speed of your system will be increased enormously, and the idealness of your system will be reduced to 10%. Of course, nowadays Core i3, Core i7 are so some other high-end processors also available, and high-end cache memory is also available. So the ideal time of microprocessor at Xeon processor, the server processor is Xeon processor XEON. Xeon processors will be there. So it is having core 16, totally 16 cores are being worked out with Xeon processors here. So the rate of transferring from cache memory to Xeon processor will be 98.2. 98.2 percentage the data will be supplied to microprocessor for its execution. So that nowadays the ideal time of your what do you call computer will be so 1.8 percentage. It has been reduced up to this particular this particular amount of time. So ideal time is very less if you consider any server. However, that is not important for us. So these are the statistics which we have to remember. So if microprocessor will be executes 1000 instructions per second, for example, if you consider in such a way, so the main memory can be supplied only 600 instructions per second. If you include cache memory in between main memory and microprocessor, it could be supplied so approximately 900 instructions per second. I'm talking about this particular hierarchy when the databases were introduced to the world, for example, 1980. So I'm talking about this whole structure in 1980, in the year 1980. Nowadays, it has been 98.2% of data or instructions will be passed to the microprocessor for its execution by the cache memory here. Okay, soon the data will be passed to the microprocessor. It will immediately fetch the data from main memory, and main memory immediately fetch the data from file system or a disk for supplying to the microprocessor for its execution. And however, you have to look into this particular area. This area is volatility, non-volatility. There are two different types of different kinds of memories are there. Some of memories will be considered as volatile memories, and some of memories are considered as non-volatile memories. Okay. However, this virtual memory, otherwise a disk or file system, or territory storage, everything will be considered as a non-volatile memory. Once you have to store the data within that particular non-volatile memory, they cannot be erased unless the user wants to delete or erase that particular data. So user must be so apply some command to delete that particular data. Until then, so the data cannot be deleted. Whereas main memory or cache memory, as soon as power will be, I mean electricity will be, supply will be so off from that particular computer, the contents of main memory and the content of cache memory will be gets lost. So that is why the nature will be called as volatile nature. So we could not assume that the data will be available underworld forever within the memory. Okay, so that is the specification regarding to this particular storage. And let me explain what are the different categories of our storage here. Memory hierarchy will be at first and foremost. So we do have cache memory. Cache memory is a high-speed memory which could be supply or which could be give the information or executed instructions to the microprocessor at a faster rates. And then it could be main memory. Main memory can be gives the data or the instructions to the pass the instructions to the microprocessor at somewhat lower speed of when compared to this particular cache memory. And then the third one is secondary storage devices. We do have many secondary storage devices are there here. So secondary storage devices will be magnetic tapes. Magnetic tape will be secondary storage device, and magnetic discs. So hard disk or magnetic discs will be considered as secondary storage device, and the flash disks. So whatever the pen drives we are using right now, they are called as a secondary storage device only. And territory storage will be so the data. I mean, this the territory storage will be also called as WORM. So what does it mean? Write once, read many. Something like write once, read many. So these disks are called as DVDs, DVDs, or CDs, or Blu-ray discs. All these things. Blu-ray discs, all these things will be called as territory discs. So once we have to return onto that particular device, you are not supposed to write some more time. Whatever the data you are expected to write, so once for all you have to write, and you can read the data from the particular disk for many times. Write once, read many. So that is why WORM. The operation will be called as WORM. Okay. Write once and read many kind of things will be taken in terms of this the territory storage. And last and final thing will be virtual memory. Actually, this virtual memory is not really existed. So let me explain this particular virtual memory after some other time because it is not our duty to explain. This concept is really belongs to operating system. Okay, I hope that you people have some kind of algorithms in terms of virtual memory, demand paging, and LRU method, FIFO method, and some other methods are there. So in operating system, you could come across this particular virtual memory here. At the end of this session, I'd like to take some kind of explanation regarding to this virtual memory also. Okay, so these are the different kinds of memories which are available within the computer to execute some set of DBMS operations here. So to store the data and to fetch the instructions from the storage and to execute the instructions from the storage. Okay, these are the memory hierarchy. And let us come across with the magnetic disks because nowadays people are using magnetic disks, variety number of magnetic disks which are available in the market, and they are used for storage the data and storage the instructions in the form of programs. It has been used. Look at this. I'll give you the complete. Yes, this one. Magnetic disk will be seen in such a fashion. So you could see this is one particular disk. This is second disk. This is third disk, and so on. Many disks will be spindled. So this is the spindler actually. This is a spindler. The spindle is always trying to rotate the disc at a faster rates. So the rate of the speed of this particular spindle will be 7,500 RPM. RPM in the sense rotations per minute. Okay, 7,500 rotations per minute it will be taken. So during that particular rotation, yes, the data will be captured and will be taken from the disk and it will be sent to the main memory for further uses by the program or by the microprocessor. However, so most probably what I would like to say, everything I am discussing regarding to so the invention of this databases at 1972 and the invention of this magnetic disk at 1980. I'm talking about 1980 or 1984 or otherwise 1984. These two, either of these two, I'd like to consider. I have to discuss all these things in this fashion here. Right now, we have only one disk. Only such kind of this kind of disks are available with any hard disk, but one only in laptops. So you do have only one disk, but that is high density disk. Let me explain what is that high density. So there are in olden days there are 8 plotters will be there. Each plotter in the sense this is one plotter, one complete disk. This is another disk, and this is another disk. Each disk will be called as a plotter. 8 plotters will be available, and both sides of that particular plotter, the data will be written so that 16 surfaces will be available for any hard disk. Okay, for any hard disk, if you consider the 8 plotters or 8 disks are there on both sides, data will be written so that 16 surfaces will be there. So lower side, upper side, lower side, upper side, and so on and so forth. We do have 16 surfaces will be there. There are 2 power 16, otherwise 65,536 tracks per second. Let me display this one also. Look at this. These are all tracks. So first track, second track, third track, and so on and so forth. These are all tracks. All these things will be called as track. I hope that everybody have some kind of idea. In every school, we have running track. Running track will be a circular shape, and the people will be get run through that particular circular shape. So that is called as a track here. So such that we do have approximately 65,536 tracks will be there per surface. Okay, upside so 2 power 16 tracks, and the downside, I mean lower side, 2 power 16 different tracks will be there. And for every track, we do have 2 power 8, otherwise 256 sectors are there. Look at this. This is the data, the area which is being plotted in between these two lines. These two lines will be called as a sector. That is called as a sector here. Per sector, let me consider. I'd like to copy this particular diagram to somewhere else, and let me explain in a proper way. So let me come back. I'll come back one more time. Let me take this particular diagram and paste it somewhere else. Okay, let me paste here itself. New slide. Let me take this slide, very new slide, and like to paste here. Yes, I'd like to drag like anything, then you could understand very easily. So look at this. So let me go ahead with explanation. So look at this. So this particular thing. So the area which is being plotted in between these two will be called as a sector. Already it has been given the sector here. This is the sector, and each and every, so the circular form of each and everything is a track. So and then in between one track to another track, there is a very huge gap. That is, black line has been given here. This black line is called as gap between one sector to another sector. However, the data which is being stored within this particular area. Let me take another color, then you could understand very easily what I'm talking. So here, the data which is being stored in this particular area, is 4096 blocks. Sorry, bytes. 4096 bytes. That is, which is also called as 4 kilobytes. 4 kilobytes of data will be stored within this particular area. Okay, this area, technically speaking, this area is also called as a cluster. So after invention of what is that? Data science, data warehousing and mining, cluster. The word cluster has been eliminated from the storage devices. This word has been called as a block. It is called as block. Cluster in the sense similar items will be get together will be called as a cluster actually. So nowadays, in this government, we are holding we have one particular word cluster, something like that. So, however, so this is a particular block. This particular block will be have a capabilities to store. So let me come to that particular area. Yeah, to store. So 4096 bytes. 4096 bytes totally. Okay, 4096 bytes. What does it mean? It is 4 kilobytes. So each and every block which is going to be stored within that particular area, within the particular track and sector. So the intersection of a track and sector, so it could be able to store 4096 bytes. Okay. So this is what about magnetic disk, and there are several number of times which are used to get the data from magnetic disks here. What are those times? Let us have a look here. What are the accessing storage characteristics here? Let us have a look. So accessing storage will be accessing in the sense of reading and writing the data onto the disk. Reading and writing the data onto the disk, and each and every reading or writing onto the disk will be associated with the 3 different types of delays. Okay, as a delay. So how many delays are there? 3 different types of delays are available. First delay will be seek time. So for example, as far as let me come to this area. So as far as this particular diagram, so let us consider this is the first one, this is second one, this is third one. Let me address everything: fourth one, fifth one, and so on and so forth. Sixth one, seventh one, and eighth one, and so on. This is the 9th address, 10th address, and so on. If you address each and every block of this particular area, you do have many number of blocks, and each and every block does have its own address. And your head will be reading head will be available at a place. So for example, your reading head will be located here. For example, your reading head will be located here in this previously I have read the data which is resided at this particular block. Now I need some more data which is being executed right now. So then the head must be moving from here to somewhere else. For example, the data which is required to store, required to execute will be available at this particular location. For example, at this particular location, the data which is being executed will be available here, and my head will be available at this location. Then what exactly it could be done? It could be identify the address where exactly the data which is being used to execute right now. So it will be, the disk will be moved from this place to this place here. Okay, the disk will be moving from this place to this place here, and head will be always constant. It is always constant, so it could not be moved so as like a circular way. So it could be moved back and forth only. It could not be moved as a circular way, and head will be available at this place, and my data which is going to execute right now will be available at this place. So it could be search for the address here. The searching time will be called as seek time. The searching time which is called as seek time. It could be always looking for the cylinder which contains the block where exactly. So it could be located by the block here. This identification of the block location will be called as seek time. Okay. Then after identification, so-called disk will be moves that particular already existed place to the available place here. So that kind of latency will be called as rotational latency. Okay, this is also some time. This is also some other time. And so after rotational latency also gets over, then we would like to pick up that particular data, read that particular data from the sector. So to read that particular data, which is called as transfer time. Okay, transfer time of that particular. Okay, however, let me explain by taking one particular example. Then let me explain by taking one example, then you could understand very easily. So let me give you. So you are right now at let me say, so 404075. The address of one particular track is one particular block is here. You are at this particular place, and the data which is used to execute will be available at 7,000. So 586 at this location. The data what we are supposed to execute will be available at this location. Okay, let me consider seeking time will be so 10 milliseconds. Okay, let me take in terms of seconds only 10 seconds. For everything, it is 10 seconds. This is seek time. ST will be so this much. Rotational latency RL will be rotational latency will be again 10 seconds. So, and the transfer time or RT, transfer time will be again 10 seconds. For example, if you'd like to consider so something like this. So you are residing, your head is residing at this location, and the data which is being executed will be available at this particular location. So that after identifying this particular address, so the seeking time will be 10 seconds. So identification of time will be, sorry, block will be taken 10 seconds plus. After identifying, the disk will be rotated at a faster rate, and it will be reached. The address will be gets reached by the head at 10 seconds plus. After reaching that particular place, it could be read out the 4096 bytes. So to read and transfer the 4096 bytes will be taken again 10 seconds. So totally it will be taken 30 seconds of time. It is not actually seconds. It is 10 power 10 seconds, something like that. Petaseconds. We will call it as petaseconds. However, we are not interested in this one. We are talking about more in terms of seconds. So from disk, if you want to fetch 4096 bytes of data, so it will be taken this much amount of time. Okay, seeking time must be there, and then followed by rotational latency must be there, and then followed by so transfer time also be there with you. So to identify or to get the 4096 bytes of information, 4 kilobytes of information from the disk, it will be taken this much amount of time to transfer. Okay, so these are the disk access characteristics. So let me give you one specific example. So this is the specific example where exactly I'd like to consider here. So by taking this particular total example, you could understand how much time will be taken to get the data from a magnetic storage device to the main memory. Okay, this much amount of time will be taken to transfer the data. So from magnetic storage device, let me say hard disk to main memory. So this much time, much time will be always consider that the CPU will be under waiting mode. So because the data is not available so far, so that it could be wait for some time, so to get the data from magnetic storage. So that is why the main memory and the cache memory was introduced in between CPU and magnetic storage, so that the CPU's so waiting time will be gets reduced. Tomorrow, I would like to consider what you call indexing, how the indexing will be, and how the data will be stored on the magnetic storage, and how indexing will be framed, how many types of indexes are there, and are there any other access methods which are used to get the data at a faster rates will be discussed tomorrow. Okay, let me take the attendance for a while. You please